Okay, good morning, afternoon, or evening, everybody. Welcome to the Explore GIS efforts that enable Earth science at NASA's Goddard Earth Sciences Data and Information Services Center, or GES DISC, Earth Data Webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Time, so we're going to go ahead and get started here. What I'd like to do first is begin today's webinar with a few webinar logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any questions or you have any issues, what I'd like for you to do is enter those into the Q&A panel rather than the chat located on the right side of your screen. Today's webinar is being recorded. The recording will be posted to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a couple weeks of completion. Once completed, I will send an email to all registrants with the recording links and also a link to the presentation slide deck that was used in today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstrations and an additional 15 minutes for the question and answer period. During today's webinar, our speaker is Alison Alcott. She is a scientific programmer at the NASA GES DISC, and she will begin today's webinar. Let me go ahead and pull up the agenda here. Hold on just one second. She will begin today's webinar with an introduction to Geographic Information Systems, or GIS, and the ArcGIS Cross-Stack Collaboration. From there, she'll transition to a series of image services demonstrations, and we'll wrap up her presentation today by highlighting GIS learning resources and documentation. After our speaker has finished with her presentation and demonstrations, we will transition to an optional final set of polling questions. I will give these questions, 10 to 15 minutes or so, so even they'll be present while we enter the Q&A period. During this afternoon's Q&A session, we will have Dr. Benita K.C. with us. She is a data scientist and user needs lead at the Goddard DAC and will be available to help address your questions. Depending upon the questions that we receive today, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. Eastern Time. And just a quick note about the Q&A period. We will try to answer all questions within the time allotted, but if we're not able to address your question during Q&A, our speakers will be able to follow up with you offline. With that, it is my pleasure to introduce today's speaker, Alison Alcott. So Alison, let me stop sharing and I will pass the presentation role over to you. Give me just 1 second here. Sorry about the delay. Got the mouse a little. Alrighty, Alison, you should have presenter role now.
All right, thank you, Jennifer.
You're very welcome.
I'm Alison. I'll be giving today's presentation on exploring the GIS efforts that enable Earth science here at the Goddard Earth Science Data and Information Center. And I'd like to thank my collaborators, Benita, Jennifer, Mike, and Andrew. So as Jennifer mentioned, first we're going to have an introduction into GIS and some of the cross-stack efforts. Then we'll get into demos on a specific image service and then the applications of image services. And throughout this presentation, we'll have demonstrations on using Jupyter Notebooks to open image services in both web portals and ArcGIS Pro, and then where to find NASA image services. So just a little bit of background on GES DISC. We are one of 12 NASA distributed active archive centers, or DACs, and we store, maintain, and distribute NASA Earth science data sets to users. Each DAC has a general theme usually, and ours is atmospheric composition, water and energy cycles, as well as climate variability. And on the right here, you can see a map showing where each data center is. We are located at Goddard in Greenbelt, Maryland. So what is GIS? GIS, it stands for Geographic Information Systems, and it is a general term for tools that involve visualizing, storing, analyzing, or sharing geographic data. Many of these tools are open source, some of them are proprietary, and there's a combination of desktop applications like QGIS or Esri's ArcGIS Pro and ArcMap, as well as some web GIS applications, for example, ArcGIS Online or AGOL. And ArcGIS Online specifically is supported through organizations, but it still has free to access public content. So the reason we're trying to support GIS, even though some of the software is proprietary, is that it has a lot of benefits. For example, it can be used to view data at any spatial scale. So you could use GIS tools to look at a single building or the entire globe. It's also useful for looking at multidimensional data sets, whether they be spatially and time distributed, or they just have multiple variables. And it can be used for raster and vector formats, as well as data sets from multiple different sources combined into one map. GIS software is often interoperable with Python code or Jupyter Notebooks, and there will be a demo on that in a moment. And this could be used to customize or automate analytical workflows. And another big reason we're trying to support more GIS options is, according to the American Customer Satisfaction Index survey that we've been conducting over the past few years, our GIS user base has been increasing greatly, and it is the #1 tool that our users use to analyze and process our data. 47% of our users responded that they used GIS tools in 2020. We've also had some direct user feedback, whether that be from conferences or our help desk asking about GIS. So while GIS is, ArcGIS specifically, is proprietary software, it does facilitate NASA's open science policy, which is the open sharing of data, information, and knowledge within the scientific community and the wider public for the purpose of accelerating scientific research and understanding. The reason that ArcGIS can do this is due to the standards set by the Open Geospatial Consortium, which sets standards for GIS services. These standards ensure that the services can be interoperable among proprietary and free GIS software, and they also standardize the format and data quality, as well as the documentation surrounding these services. Image services are also publicly available through ArcGIS Online, free, and specifically NASA ArcGIS Online. And these services are compatible with, as I mentioned, non-ArcGIS and ArcGIS software. They can also be viewed using Python scripts or Jupyter Notebooks. So one of the bodies that has been pursuing more GIS applications across NASA is the Arcgistak Collaboration. And this is a coalition of participants that are working to expand the implementation of GIS tools across the Earth science data systems. And the Arcgistak Collaboration has members from almost all the DACs, as well as other teams such as the Earth Science Applied Sciences Disasters Program, GIBS, and even we have collaboration with Esri directly. So through the Arcgistak Collaboration, we produce web maps and services that are collected on NASA ArcGIS Online. We also are working on expanding our user outreach, making sure we have good documentation and tutorials to help users with our products, and participating in workshops, conferences, and webinars just like this one. So here I will be demonstrating I've recorded a demo of a Jupyter notebook. This notebook will be refined and posted on the GES DISC website as a tutorial in the future. In this demo, I'll be showing you how to view an image service and create a custom workflow using that image service in a Jupyter notebook. Now, this notebook can be run using any means that you would normally run a Jupyter notebook. It can also be run using GIS clients like ArcGIS Online and ArcGIS Pro. The first step for running this notebook is to import all of the tools we need. So from the ArcGIS library, we'll just import all of the raster tools. Then we specify which image service we would like to use. And in this case, we'll be using a GES DISC image service for GPM iMerge, the early data product. I will go into more detail on this image service in the presentation, but for now, I'll just say that it displays precipitation rate in a unit of millimeters per hour. So we can run this and display the image service in the Jupyter Notebook. And here it is. The next step will be to take a look at some of the raster function templates that come built into the image service. So in the second cell, we can list all of the raster function templates that the service comes with. And that runs very quickly. And then the third cell, we can apply one of those raster function templates to the data set. So you just say apply, specify the data set, and then specify which template you'd like to use. So in this case, we'll use GPM green red mask. So this will mask out all of the zero values, display low precipitation rates as green and high precipitation rates as red. So you can run that. And all of these images are showing just the very first time slice in the image service. But if we wanted to look at a specific event, we could specify which time slice. So for the rest of this Jupyter Notebook, I'll be using it to calculate some statistics on Hurricane Ida just before it made landfall. So to do that, I'll specify a time, and that time is going to be October 29th at 12:30 a.m. And then I have to specify a location. So I'll specify a box right around where Hurricane Ida was at that point. And then using that, I'll create a statistics histogram. So first, to specify the time, I create a new variable and assign that specific time slice from the data set to that variable. So that time in the GIS format would be this number, and then we can view that time slice. Right, and here it is. This area in the upper left quadrant right here is Hurricane Ida. Now, we don't need to look at the whole globe to calculate the max precipitation rate over Hurricane Ida. We just need to look at the area around it. So I've specified a 10 by 7 degree area around it, which I have assigned to the variable Ida right here. And then to compute the statistics in histogram, you just run the compute statistics in histogram function on the data set and specify the time and the area. So here we specified Ida and the same August 29th at 12:30 a.m. And then we can get our output of the statistics. So here it lists the min is 0. I must have included some area that was outside of Hurricane Ida that had no precipitation. And the max is right around 35.2 millimeters per hour. So this is just an example Jupyter Notebook of how you can view image services as well as do analytical processes on those image services all in one Jupyter Notebook. All right, and I would just like to point out that I misspoke in the presentation and said October 29th the first time. It is actually August 29th. So I've been talking a lot about image services, and I'm just going to go into a little bit of what image services are. Image services are a way to process and share data sets through GIS without needing to download any data. So this is both good for data providers because we can provide access to a large amount of data, and it's good for users because the user doesn't need to store or process any of it. They are very quick to open and view in GIS clients, and they can also be used when doing analysis of the data sets as well. So NASA has a lot of image services available on ArcGIS Online, and the image services can be used in ArcGIS Online. They can also be used in ArcGIS Pro and other desktop applications like QGIS. So when a organization produces image services, they're often shared through web portals. So this is where data providers can build and share image services, as well as create and share web maps, and it makes the content available to the public. It has a very simple user interface. I've included an image to the right here of the GES DISC web portal that will be unveiled in the next few days. And the web portals can also include information about the services, whether that's connections back to the original data set, documentation, metadata, just descriptions of what the service is showing. The web portals also contain a standard map viewer, which has options for analysis. The user can adjust the symbology to whatever they would like in the map viewer, and they can also use it to scroll through time and view different time slices in the web map viewer. It's also a way for not only data providers, but data users can also create and share their own web maps and apps using ArcGIS web portals. So here we just have an image of the standard web map viewer. You can see that there's the map in the middle with a frame around it, and this frame is standard for the map viewer classic on ArcGIS Online. And I'd just like to bring your attention to a few things. So the portal menu is visible and accessible from the map viewer. And there's also ways to add data sets to it, whether that's directly from an image source, image service, or browsing for imagery layers online. The content pane would show you what is in the map, and then there are options to do analysis as well as save your work in this standard classic map viewer. So the image service that I used in the Jupyter Notebook is our first image service at GES DISC, and this will be unveiled also in a few days with our web portal. The image service is of the Integrated Multi-Satellite Retrieval for Global Precipitation Measurement early product. So as I mentioned, it displays precipitation rate in millimeters per hour, and its time coverage is from June 1st of 2000 to the present with 30-minute intervals. It's a global data set with 0.1 degree pixels, and the real reason why we chose to use this data set is because it has a very low latency, meaning that it produces this imagery very quickly, so you can see it in near real time, which is important for if you're doing any sort of disasters monitoring or, for example, storm tracking. Watching the data in real time as it evolves is going to be really important for that. So that's why we're using this image service first. It's also updated throughout the day, so you have the data as quickly as possible in this GIS format. And as I mentioned, and I believe I'll mention it in the recorded demos as well, this is actually not publicly available right now, but within the next few days it will be unveiled on the GES DISC website. All right, so I'm going to be showing you how to use this image service in the web map viewer. In this demo, I'll be showing you how to navigate around GES DISC's ArcGIS portal, as well as opening an image service in the web map viewer and some of the options that come along with the web map viewer. So first, let's take a look at the homepage of GES DISC's portal. A link to this page has been provided in the chat already and will be provided again at the end of the presentation. And everything on here is publicly available. You don't need to log in to see anything that I will be doing today. The first thing you might notice is the featured maps and apps section. This is just some content that we've chosen to promote because it might be interesting or important for users to see. There's also a short description of what the portal has to offer and some direct links to the content in the portal. To take a more detailed look at the content, you can go to the Gallery tab at the top of the page. And you can see all of the content in the portal in either list or grid view. If you'd like to filter by a specific content type, for example, if you're looking for only web maps, you can filter that on the left here. So here you can see we have the image service itself, we have a web map of the image service, and we have a web app, and we have even more content below. Let's take a look at the web map first. We have the landing page for the web map. It contains information, just a brief description of the web map. It also contains a more detailed description of the data set itself, a link back to the GES DISC dataset landing page, as well as information on the settings of the web map and the built-in raster function templates using these color bars here as a legend, so you can preview them. There are a couple ways to open this web map. The first one is in a desktop client, so you can choose whether to open this in your own local version of ArcMap or ArcGIS Pro, but today we're going to open it in the map viewer here online. So here you can see the description. We have a legend and content on the left, and the image service loads in the map. You can see that there is a time slider here at the bottom, and this web map always opens to the last time slice of the previous day. And without doing anything, you are able to zoom and pan around. You can also animate through time. Again, you don't need any sort of sign-in to be able to do this. And if you'd like to modify the map or customize it for yourself while viewing it, you can click Modify Map in the upper right here. So some of the things I will be showing you next are kind of an extension of the Jupyter Notebook demo previously. So it will show you some of the aspects of what you can do in a web map while also continuing our look at Hurricane Ida. So the first thing we can do is change the date of what we are viewing. To do that, you go to the time slider menu here at the bottom, and you click Show Advanced Options. And we were looking at August 29th, 2021 at 12:30 a.m. before, so we can put those into these drop-down menus. And I'd also like to note that the image service time interval is set to 30 minutes, as that is what the data set is also created in. So those parallel each other. All right. And then we can move the time slider back to August 29th at 12:30 a.m. And here we have Hurricane Ida. Now, if we zoom in, we can also view a pixel value to see if our calculation of the highest precipitation rate in Hurricane Ida at this time was close to what we're seeing here. And so the bottom, like kind of in the middle here, seems like the highest precipitation rate. So we can just click on a pixel and we'll get a pop-up saying what the precipitation rate of that point is. So 29.7, that's fairly close to the 32 that we had from the Jupyter Notebook. So we can see that that is very similar. Next, we can also customize the symbology of this map, just like we did in the Jupyter Notebook. So to do that, you go to the layer, and this is our iMerge image service. You click the three-dot menu beneath the layer name, and then you can click Image Display. And this has a bunch of different settings to customize the image display. Right now it's set to one of the standard raster function templates that come with the service. And you can see those other templates with a description of what each one is here, along with thumbnails. Let's customize ours on our own. So we can do a user-defined render. and we hit apply. And there's the image service with no template on it whatsoever. So in order to see what the scale of what we're looking at, there are a couple of different ways to view the legend. So you can either click this tab here. Now this is a 0 to 250 scale. Or you can go to content and there's a little legend drop down beneath the layer name. So we can change the color of what we have here to make it a little bit easier to see. Go back to image display. And we can specify stretch and what type of stretch we would like. So we can do standard deviation and put in our own statistics for this layer, and we can also specify which color we would like. So a very common precipitation display is green for low precipitation, red for high precipitation. So we can select that, hit apply, and here's our map. All right, let's go back to the original raster function template GPM log spectrum. That way we can see a little bit of the base map. Now, there are other options for the base map that are included in the web map viewer, or we can add one ourselves from we can search for one from Living Atlas of the World. So these are all public, well, these are the content from the GES DISC web portal, but if you take this drop down and go to ArcGIS Online, these are all publicly available layers that you can add to your map. Again, no login needed. For this example, we can choose, let's try hand sharpened Landsat. So this should give us a nice high resolution image of Earth's surface. And we can add that. And go back to content and make sure that that is below the image service. To do that, you can go to the three-dot menu and click Move Down. Now we can see the image service right over top of this high-resolution imagery. We can also turn layers on and off. And we can share, we're able to share web map links directly from the web map itself. All right, so that was showing you how to open an image service in a web map viewer. There are a few other methods of doing this, but this is just one of them. And I also showed you some of the options of what you can do once you're viewing a web map in a web map viewer.
All right, so I will once again point out that this image service and the GES DISC portal are not available today, but within the next few days, we'll have an announcement on our website, and we will be providing documentation on some of the other ways to open image services in a web map viewer. So the next slide will be showing you some of the ArcGIS Pro capabilities for image services.
In this demo, I'll be going through a workflow in ArcGIS Pro using the GPM image service that we've been using. So the first thing to do to get the image service into Pro, there's a few options for this. We'll be using the direct link method. So I've provided a direct link to the image service right on the homepage of the GES DISC web portal. So all you have to do is right click and copy that link. You can also go to the image service landing page and copy it from there. And then in Pro, you go to have your map open, add data from path. Paste the link, click add, and the image service will open up right in the map viewer in ArcGIS Pro. It takes a second to load, but it will open up just like in the online map viewer. And you have the same options for scrolling and panning, zooming in, as well as a time slider option. For this workflow, the end goal will be to take a look at Hurricane Ida once again,
and try to convert the units from millimeters to inches. So first, in order to do that, we are going to look at the time. So if you go to the time tab, that should open when the map opens. We'll put for start time in, we can select from the calendar. We've been using August 29th at 12:30 a.m. So you can type that right in. We've also been using a 30-minute time span, because that is what the data is in. And it jumps right to it. So here we have Hurricane Ida, once again, just about to make landfall. The next thing we're going to do is take a look at how to adjust the symbology in ArcGIS Pro. There is a symbology pane. I have it open on the right side here, but you can also right-click and go to Symbology from the layer to get this pane open. The first thing we'll need to do is remove the raster function template. So right-click on the layer name and go to Properties. The last option should be Processing Templates on the left, and then you can go to the drop-down and select a processing template that you'd like, or none at all. And then click OK. Just like in the web map viewer, it'll look very dark now, but you can adjust the stretch type. We'll go with standard deviation. And the color scheme. This is all customizable. You could put in your own statistics if you'd like. We'll just go with the data set calculated ones for now. ArcGIS Pro also has an option to mask out the zero values. So in the bottom part of the symbology pane and the mask tab, you check the box to show 0 as no data. That will remove all the background values. All right, so we are zoomed in on Hurricane Ida. Next, what we have to do is pull up the raster function for the unit conversion. To get to the raster function search, you can go to the Analysis tab at the top and then click raster functions, and it will pull up this pane in which you can search for any raster function. So we will be doing a unit conversion. And just to speed it up, we'll only do this unit conversion on the scenes that we're looking at for Hurricane Ida. So to take a look at which perennials we're talking about, we can look at the attribute table. And there are 2 here. So we'll select both of those. Right-click on the layer name, go to the selection option, and then add to map. So we'll call these 2 scenes that we're looking at, specifically about Hurricane Ida, we'll call those Ida. And this will make another layer with just the 2 scenes that we've been discussing, exactly the same as the previous one. It's just a little bit smaller, so the analysis will go faster. So next we can select the raster that we'll be doing the analysis on, so that would be Ida. And we are converting from millimeters, which is what the data set is in, to inches. And then you select Create New Layer. And we have a new layer of Hurricane Ida in the unit of inches. So we can take a look at the pixel values right in the middle of the spiral for the old Ida layer. We have a pixel value of 40.91 millimeters per hour. When we take a look at this one, that converts to 1.6 inches. So that's a workflow showing you how you can convert millimeters to inches and also open an image service in ArcGIS Pro.
All right. Oh, sorry about that. So now we've talked about image services and a few of the ways that they can be used in different clients. Now I'm going to be discussing some of the applications of these image services. So why do we want to use them? Image services can be used in combination with others to create a larger story or communicate more information in a web map. So a web map is just a collection of layers in the map viewer or desktop client. You can configure the symbology and time like I showed in the demonstration, and also do analysis, leave bookmarks of important points, everything in the web map viewer. A web app is kind of one step beyond a web map. So it is a web map just with some set configurations by the person creating the web app. You can customize the layout so that you have widgets that can do specific tasks, for example, a slider so you can see more than one data set at once. And web apps also have the benefit of being really easy to embed in websites, and also they can be mobile friendly, so you don't even need to view them on a laptop. A story map is one step beyond that. So a story map is just a combination of maps and apps along with text or other media types like images, still images, or videos or audio, anything you could think of in one kind of linear reading story map. And those just provide a lot more context to the data sets that you're looking at and what they mean and what information can be taken from them. So in the images here, we have a web map in the upper right in the standard web map viewer frame. And then this middle one is a web app. So it's a little bit small, but you can see little widgets in the top right and top left. And I'll show you a larger example of this in a moment. And then we have the web app, or the story map, which has the web app embedded in it, along with text and images. So the Arcgistak Collaboration also has a subgroup that is working to create web maps, story maps, using data sets from all across NASA on a certain theme. So right now we have one story map about drought, which is complete and viewable online, and I've provided a link to that during this presentation. And we're currently working on maps for flooding, tropical storms, fires, and air quality. These web maps, we're using near real-time data so that they can be used for monitoring events. For example, a drought, you could just log into this web map and see what areas of the world are in drought, how severe it is, and some of the aspects that are contributing to drought around the world. And these data sets and image services that we're using are from multiple DACs and science groups all across NASA. So one place of finding these web maps that I've been talking about is the Earth Data GIS Pathfinder. So the Pathfinder has links to the Arcgistak Collaboration web maps, as well as information on what NASA image services are available and documentation on how to use services. Both the Arcgistak Collaboration and GES DISC specifically are also working on how-to articles, video tutorials, webinars, just like this one. We've also worked with Esri directly on blogs, just showcasing how our data can be used in GIS and some of the benefits of it. So in this final demo, I'll just be showing you some of the ways of finding ArcGIS image services from NASA.
In this demo, I'll be showing you some other sources of finding NASA GIS content. The first source that I'll be showing you today is NASA ArcGIS Online, or NASA AGOL. This is a centralized collection of data sets and web maps and apps and story maps from all across NASA. It's all available here. Everything I'll be showing you on NASA AGOL today is publicly available, and you'll be able to access it just the same as I am right now. The links to NASA AGOL and the other source of GIS information from NASA that I'll be sharing today have both been shared in the chat and will be shared again at the end of the presentation. So here we are on the homepage for NASA AGOL. You scroll down, you can see some featured content. This is some GIS hubs and story maps and web maps on different environmental factors or on just GIS at NASA in general. And to view all of the content on NASA AGOL, you can either click View Gallery down here, or you can scroll all the way up to the top and click the Gallery tab. Here we have all of the content that is publicly available from NASA AGOL. It can be filtered by content type on the left here, as well as searched by keyword at the top. You can view it right here on NASA AGOL using the map viewer. To view the same map viewer format as the GES DISC map viewer, you can click Open in Map Viewer Classic, and it'll be exactly the same. So that's NASA ArcGIS Online. The other source that I'd like to talk about is the Earth Data GIS Pathfinder. The Earth Data Pathfinder describes a little bit of background on GIS before going into some different methods of using GIS, specifically with NASA data, whether that be multi-dimensional data in general, which a lot of NASA data sets are, using NASA data in GIS with specific tutorials, providing different use cases for some of the data sets that are provided. It also goes through some different ways of discovering GIS content at NASA. AGOL here you can see is mentioned, as well as Worldview is a good source of GIS data, and just an Earth Data or a DAC search. One type of content here on the Earth Data Pathfinder that I'd like to go into is the Thematic Applications tab. This contains the content from the Arcgistak Collaboration web map group. So in this group, we've been creating web maps and story maps to explore data sets from all over NASA that all relate to a specific theme. So the web map itself is embedded right in the website. You can interact with it directly there. You can view the legend as well as the different layers that are included. And you can also, for this specific web app, you can view the time slider and adjust that and view multiple layers all right next to each other using a swipe layer. For more information on this specific app, we have a story map that goes along with it, which can be accessed at this link here. Now, this is an example of a story map. As mentioned during the presentation, a story map just combines web maps with other media types of media and text to give a fuller picture of what you're looking at in the map. So this specific map was created to monitor drought. So all of the layers are updated in near real time and all relate to drought in some way, whether that's a cause or an effect of drought. You can see the same app is embedded right here, but a little bit larger, and it can be interacted with in the same way, with the legend and the swipe layer. Each layer in this web app has also been embedded below and has a detailed description on what the layer shows. So those are some of the sources of finding NASA data for GIS and some of the resources that you can use in GIS.
All right, so that was the final demo for today, and that was all of the content that I had to share with you. So now we're going to open it up to questions, but first I'd just like to give special thanks to these people who contributed to this presentation or the GIS efforts in general. And once this this presentation is shared, you'll have all of these links available through that.